I feel like I'm amongst friends here. I've ploughed my lonely furrow with living walls for the last 9 years, and then everyone's on the bandwagon here. So my name's Angus Cunningham. Thanks for inviting me to talk today. I want to talk about living walls, which is my passion and what my business does, and their impact on internal air temperatures. Our business is involved in green infrastructure. We have a niche market. It's driven, I think, largely by planners now. When we started with living walls, it was a kind of a Chelsea and Kensington market, very expensive. But in the southeast, planners are now demanding that buildings are covered with greenery, be it a wall or a roof. So we want to introduce sustainable landscapes in the built environment to make everyone feel better and make them healthier places to live. So what is a living wall? In the 80s, when I moved down to London to make my fortune, this was a living wall. It's nothing wrong with it. It just took a long time to get up the building. It's a climber, and often climbers up buildings in London are deciduous, which means they drop their leaves in the winter. What we've got the technology to do now is to give living walls, this is one in Sheffield, instantly. This took a week to put up. And we can be careful with the planting. We can make sure there's something green there all the time, so we're maximising the effect. This is in London. This is 14 stories up on a building in Hackney. Iconic shot of our abseilers maintaining it. Shouldn't really be like that. It should have been thought about when the wall was put up, because you don't really want your abseilers bundling down the wall, damaging the plants. But it just gives you an idea of where we can put living walls. It's not just exterior living walls, interior living walls. Great for air temperature. I'll come on to that towards the end of this talk, but huge demand. But before it was all external. I think the shift, we're now 30% internal walls. Why limit living walls to walls? Why not put them on gates? This is a 5-metre column at our HQ with a strange cone at the top. And there's another shot of the cone planted. The point we're trying to make is that you don't need a horizontal border to put plants in. I am a tree hugger. I do like putting trees in towns, but there are restrictions where you can put trees. But if you go up to the centre of London, have a wander around, there are no horizontal spaces. You've got road, pavement, building. But if you look at the vertical surfaces, I have acres of space. And it's one of my legacies. I would like to put a vertical meadow in the middle of London and see birds and bees on it. Bulbs work well in living walls. There are no limits. Believe you me, there are no limits. Living walls are easy to do and they're commonplace. We've put in over 35,000 square metres in the last 6 years. Here's an iconic one in Germany, interior wall. Just let your imagination run riot. You can put a living wall anywhere. And Maria, you need some around the university. Yeah. They were all aesthetics. So as I mentioned, Kensington and Chelsea was the market. It was competing with the Joneses. They looked wonderful, they looked colourful, and they were lovely. But Marks and Spencer's, interestingly, has helped drive our market. They wanted to be seen as the greenest retailer in England. They put grey water recycling in. They use green roofs. They use heat source pumps. They put LED lights. They do everything green, but they felt no one knew that they were being green. So what better way to do it than to put a living wall up? But this was the extent of the market up until 4 years ago. There was not a lot of science behind it. It was the perception that green was good. And it is. It's amazing we can bring biodiversity into city centres. But I think listening to everyone here, there's been a lot of research over the last 3 and 4 years of the extra benefits that living walls can bring. And that's what we explored with the Sheffield University. But before I jump onto that, it's interesting to note that there is a big market for living walls and green roofs. This is cladding buildings. And a couple of points on here. One is London is seen as a kind of a driver. So in the southeast, we're in a bubble. We're seen as market leaders. So the world is looking at us, what we're doing here. And also costs. You'll see that the green roof and living wall market is worth $7.7 billion worldwide. Green roofs have the majority share because they're cheaper. But living walls, they are more expensive, but we want to validate why living walls work, and that's what we're doing today. We're all saying we want to put green in cities, we want to insulate buildings, we want to make the place more sustainable. So we teamed up with Sheffield University. This was in 2012. That's why I mentioned ploughing our lonely furrow. It cost us 25 grand. We funded it out of our own cash flow, but we wanted to see what thermal benefits living walls brought to buildings. So there was a lot. It was a bit like wandering around this university. We had to do a fair test. We needed 2 rooms exactly the same. Here's the shot. So here's the trial wall on a building, a classroom at Sheffield Uni, and immediately above our living wall was another classroom identical, which didn't have a living wall on. So we were able to put sensors in both locations. So yes, here you see the wall, and the above is a classroom. So here we used 5 different living wall systems for this experiment. And at the base of each wall, so the wall measured 5 meters long by 3 meters tall. The bottom layer was just the living wall system with compost in it, where compost was used, or if it was a hydroponic, the actual hydroponic material, without any plants. The next layer up was the fully fledged living wall with compost and vegetation, and the top one had an extra layer of insulation, and the one above that had the living wall system without compost or plants. So we had loads of sensors, we had loads of reports. So here you can see where we positioned the sensors in the vegetation, in the living wall, in the gap between the living wall and the building. There always will be an air gap, and in the classroom on the inside. We were measuring water consumption, but that's a story for another day. So what we wanted to figure out was how good living walls were at A, keeping the heat in the winter, and B, keeping the heat out in the summer. So now, I'm not an academic, I know the room is full of them, but we had reams and reams and reams of information. So I've just taken a snapshot of July because it was a particularly hot month. The black lines is the external surface of the building, the brickwork. In fact, in Sheffield it was stonework. But you can see it was touching 45 degrees, which is quite amazing. This is the sun's rays heating up the fabric of the building. The myriad of different coloured lines beneath that were the various sensors in the wall, but you can see automatically there's a quite flattening exercise. So even though the building temperature was 45 degrees, our sensors were giving a report in the wall and behind the wall of down nearer 15 to 20. And the lower graph is giving a sort of expansion of 2 days worth, so you can see how they work. Yeah, basically I've said this, it was quite interesting how hot the external fabric of the building got, and how much a difference the living wall made. In the winter, we had a similar result, although the peaks weren't so great and the flattening out wasn't so good. With the end result was that it was still effective. Living walls were quite effective at keeping the heat in, but not as good as keeping the heat out in the summer. And we had a difference of 2 to 5 degrees behind the wall with no vegetation, and interestingly, 4 to 7 degrees behind the wall with vegetation, which shows that the leaves actually do insulate. But the key points here for the Sibsey lot are that we had 100% saving in aircon. So if we're trying to keep the building cool in the summer, we'd use 1685.
Does that mean you did no cooling at all?
No cooling at all. So this was of particular interest to Marks and Spencer's because they spend a fortune cooling their buildings. I'll elaborate it in a minute. But it showed there is a huge difference in keeping the building cool with a living wall. And it's largely because we've created shade.
That's just for the conduction, nothing to do with windows and so forth.
Correct. So I'll come on to this because this was a test on one wall. Converse, in the winter, we were fairly efficient at keeping the heat in, but not nearly as remarkable results as keeping the building cool. So, as I've just said, we're good in the summer, but my problem was we'd spent all this money on research, and yes, we can see that living walls make a difference, but we wanted to be able to say to the builders, to the architects, to the planners, when we put a living wall up, it will give you this, we can work out a U value that it's given. But with the walls you can't, it would depend what sort of foliage you leave, you had, what plants you used, what size of foliage, how wet the compost was, whether the living wall was north, south, east or west facing. So what we did to get around that problem, we developed, this is our living wall system, we inserted a pocket at the back in which you can put insulation. So an architect can specify a particular type of insulation, put it in the back of the living wall, so we can give a U value for that building. So what essentially we can do, and it's more suited for older buildings which don't have the high U values that modern buildings get, but we could wrap, in theory, a building in insulation, and hey-ho, it looks brilliant because we can put a living wall in front of it. I mean, all the benefits that green and insects and birds, bugs and bees into city centres bring. So that's where we've got to. I've recently heard it's called thought leadership. You have a thought, you do the research, you then produce the evidence, and everyone goes, well, hey, let's put all our buildings, cover them with living walls. So air quality, that's my bit on living walls and our research of how they affect internal air temperatures. We've recently teamed up with a company in Germany called Art Aqua, and they've produced, they have a science, they kit out offices, and they started off as a company who put partitions up between office space, basically partitioned up offices and where the photocopier went, etc. And then decided to get green about 20 years ago, and then they introduced a science behind the green in offices. And we've been out to have a conference with them, and we're very keen to bring their products into the UK because they're all into the biophilia, humidity in offices, the cooling of the air, etc., etc. And they gave us some quite interesting facts that each human being, well, not each human being, but on average, every day we would eat 1 kilogram of food, we'd consume 3 kilograms of liquid, but most importantly, we consume 15,000 litres of air and probably produce around about 15,000 litres of CO2. So air is something we should be looking after. I've also learned that humans as an organism perform best when the temperature is 21 degrees and between 45 and 55 degree humidity. So I look around this room, I think, where are the plants? Where's the humidity? We've got a dry heat, you get dryness at your back of the throat, it's not good for you. We spend a lot of money artificially cooling a building or heating it, but it's dry. We don't like that. When I was out in Germany, actually the air conditioning was on, I woke up with a really dry throat. It's not healthy. This actually is the office in Germany where they have masses of living walls and moss and trees, and it just feels a really good place to be. I wanted a picture of an office, a typical office. I googled picture of office, and this is what I got. And look at the plants they've got. 1, 2, 3. But I couldn't. This was the picture of the office with the most plants. And I think there's huge scope for bringing the science of what plants bring into the internal environment into the party. Now here's some living walls we put up. It's not just living walls. You can create your humidity with water features. Just water features. You have a wall of plants, philodendrons, and then you have a water feature, and you can partition up. So running through the benefits of living wall and what they do to air, which is the most important food we have, they will remove CO2. We know that. They'll remove volatile organic compounds. They're emitted from your shoe polish to your photocopier to any plastic surfaces. They increase well-being. Your productivity will be increased. They're great sound insulators. Here's some columns that we've planted up, and they're 6.5 meters tall, and they're a 300 mil diameter with the living wall fabric. So you can run these through your office. Of course, plants produce oxygen. They increase humidity. I think we should put them in gyms. Would you rather run in a concrete jungle or run in a forest? It just makes so much sense. The air close to a living wall is 2 to 3 degrees, I was going to say less expensive, cooler than cooler than the air. So they will cool. They'll cool the air as well. If you've got a living wall on the outside of the building, you'll obviously insulate it. There'll be less sick days. If you get the humidity and the temperature right, there'll be less sick days. Art Aqua told me they'd done a research, they do a lot of work for blue chip companies, and they'd kitted out the BMW office, which held 900 staff. And they did a year's worth of research on how many sick days those 900 staff took in the year preceding the greening up. Then they greened up the office, and they did another tally up of how many sick days were taken. And on average, everyone took, there were 3 days less sick taken per person. So that's 2,700 days of increased productivity just by greening your office and the humidity that it brings in. So there's food for thought. I think there's a lot of work for us to do on the interior working with the air. So here's some figures. Green, the productivity goes up 39%. Just making the place feel good with the biophilic nature of plants can increase satisfaction by 40%. If you feel happier, you feel satisfied, you can take less time off ill, and reduces sick days by 25%. So we've got to introduce plants to the workplace. We've got to introduce plants to the exterior. They do so much. Without plants, as we heard earlier, it's called a rainforest because it produces rain. We get rid of plants, we get rid of birds, bugs and bees. We get rid of invertebrates, we won't be around. It's kind of crucial to bring them in. And if we can use them to insulate buildings, as well as do all the nature bits, we're in clover. So in summary, I've seen a huge growth in living walls from the Kensington-Chelsea market days to now because it's driven commercially. And we must be taking this research into the marketplace to say we can make buildings sustainable and more habitable, and we can feel better in them. We are committed to thought leadership. We have a project going on with Cambridge Uni at the moment where plants are producing electricity. We've kitted out a bus stop. And as a result of photosynthesis in the roots, byproducts, lipids and proteins are put into the soil and bacteria eat them. As a byproduct of that process, electrons are harnessed through some carbon gauze we've put in the living wall. As a little cable comes out and a light bulb goes on. So we're exporting this to Japan, and we're also think of the possibilities. We put 900 square meters of wall around the end of the aquatic centre at the Olympics. That would have generated 4 watts of electricity, and with 4 watts of electricity you can certainly fire up the pump to keep the living wall going. So we've got to be keeping abreast of what plants can do, and not just the aesthetics, which we all buy into now, and the birds, bugs and bees, but we can get so much more out of them. And that's me.
Thank you.
Thanks very much.